All right, guys. Hey, welcome back. Week 3. And I don't mean from the beginning. I mean week 3 till we end. Till you guys are out of here. Till you guys have a good summer and off to bigger and better things. I'm pumped. Can't wait. So, with that being said, you can see that we are going to start with a new concept. And I know it's not quite probability statistics and trigonometry, but it kind of is. We're going to talk about matrices. Matrices. Now, some of you are freaking out as soon as you saw that. You're like, oh my gosh, it's a big deal. I don't know if I'm ever going to get this. Listen, we're going to do the basics. We're not going to do anything too crazy with it. So I want you just to make sure that you're all, ready to go. Just have an open mind with it, and then we'll go from there. So let's get started. Basically, matrices, what are they used for? Well, before I can tell you what they're used for, you need to kind of get an understanding of what it really is. It's basically a rectangular array of numbers or variables. All right, they usually are closed by these brackets, and matrices can be all sorts of things. Most of the time, it's just data, right? They're just data. You can use them in anything from computer graphics, programming, linear algebra, networking, all sorts of things. And I listed a few there. But like I said, we're only going to stick to the basics. All right, so let's really get into matrices and what they look like. So I told you it can represent data, right? Well, let's look at this data right here. So this is basically, if you guys remember from statistics, this is basically a table representing two different pieces of data in one, right? They're two observations. We're observing whether it's like what grade they're in college and whether they live on campus or not. So we're recording two different pieces of information for this contingency table or a cross tabulation table, right? Now, given this information, if I was just given this, I can simply put it into a matrix. Now, the thing about a matrix, what we're going to use with a matrix and not use from this is we are not going to use any labels. Nothing. No labels whatsoever. The other thing that we're not going to use is we're not going to use totals. Okay, we never use totals. So for the most part, all that we're concerned with is this information right here. And simply put, I could just put a bracket around those, and that gives me my matrix. Okay, so once again, it's just a simple way of organizing some data. So keep that in mind. It's really nothing that crazy. It's nothing, that you need to freak out about. We're just going to do the basics. Now, with that, you can see that all the same numbers are here. And I don't have any totals, no labels. All right, so that's good. I've also labeled this matrix A. Whenever we label a matrix using a letter, it's always 100% of the time going to be an uppercase letter. Okay, so just keep that in mind. So the title or a label for a matrix itself is going to be an uppercase letter. Now let's look at other things that we need to know about this. A matrix is usually represented by rows and columns. Okay, so you can identify a matrix by the number of rows and columns. It's always going to be in that order, rows and then columns. Okay, rows, you have to remember, rows are side to side. Here is row 1, row 2, row 3, row 4. So this has 4 rows. Now columns are things that, I always thought of them as things that held up buildings, right? Or held up something. A column is vertical. It's up and down. Here's column 1, column 2. Okay, so this is a 4x2 matrix. You're going to need to know how to do this. Okay, so this is a 4x2. And remember, we always do rows and then columns. Now, all the numbers within a matrix, those are going to be called elements. Now, an element is, like I said before, it's usually just a data set. It can mean different things for different applications, but for what we're, for all intents and purposes for us, it's just going to be simply called an element. Now, with this, it has 8 different elements. You can always take the number of rows and multiply it by the number of columns, and that'll tell you the total number of elements that you will have. So that's a simple little thing to remember. And then finally, let's get into this part. Elements are identified by 3 pieces. Okay? 3 pieces. 1, 2, 3. I know it looks like one number, but it's not. 1, 2, 3. What that means is this is the matrix. We always use the lowercase version when we're talking about an element. So if this is, since this is matrix A, we use a lowercase a. If this was matrix Z, we would use a lowercase z. Now, this is what row we're talking about and what column we're talking about. So remember, I always said rows and then columns, right? So matrix A, row 2, column 1. That's easy. Matrix A, row 2, column 1. What overlaps? That guy. So element A21 is really 39. So you're going to have to do this too. All right, so you're going to have to practice with me and get good at this. So I kind of broke it down for you right here. Row 2, column 1. That's what that means. If I was looking at A42, it's matrix A, row 4, column 2. Matrix A, row 4. So 1, 2, 3, 4. So this row, column 2, which would be here. So it'd be this guy and this guy. So it'd be number 37. All right. Let's try this page on your own. So now, in order to do these are the 3 different matrices that I'm giving you. What are the dimensions of each matrix? So matrix B, what's the dimensions? Remember, it's rows and then columns. There are 1, 2, 3, 4 rows, and then 1, 2, 3 columns. So let's say 4 by 3. Matrix C, there are only 2 rows. 1, 2 by 1, 2, 3, 4 columns. And then matrix D has only 1 row right here and 4 columns. All right, so basic stuff. I'm not trying to ask too much. Let's look at the next part. The next one is simply asking for elements. Now I'm going to use different colored pens for this just to help you see it a little bit. This is looking for B13. So matrix B right here, row 1, column 3. Row 1, column 3, 0. The next one says C23, matrix C, which is that guy, row 2, column 3. Row 2, then column 1, 2, 3. So that would be negative 3. And then finally for this last row, or for this last one right here, matrix D, column, or row 1, column 1. It only can be row 1, right? So that first number with this particular matrix, that first number can only be a 1 simply because there's only 1 row. But it would be right there. So it would be 4. Now looking at the last 3, matrix C, row 1, column 4. Matrix C, row 1, column 4, which would be 1. For this one here, matrix B, row 3, column 1. Row 3, column 1, negative 6. And then the last one, D, row 1, column 4. Row 1, column 4. So hopefully you're kind of getting it. This is going to be how your quiz is going to look. You're going to need to do things like this.